This is the demo for College Algebra Lesson 7. We're going to be solving equations involving absolute value. So in the preview, we found two solutions to the equation absolute value of x equals 4. There were two x values that you could plug in here. Then when you take the absolute value, you get 4, positive 4 and negative 4. We can check these solutions. We know both 4 and negative 4 lie the same distance from 0 on the number line. Visually, we could find the solution by graphing. So I could graph the horizontal line y equals 4, that's this line right here. And then I could graph y equals the absolute value of x, which looks like this, and see where the two graphs intersect. So it looks like here and here. That happens at 4 and negative 4. And we can generalize the results from this absolute value equation to things that look more complicated. If you have any algebraic expression in absolute value, not just a simple x, but something more complicated than x, like 7x plus 2 or 3x minus 1, right? Anything more complicated than just an x, you follow the same rule. If it's in absolute value and it equals c, then that whatever is in absolute value could be c, or it could be negative c. Okay. So before we get into the algebraic process for solving an absolute value equation, we'll first get a sneak preview of the solutions to this equation. We have the absolute value of 2x minus 3 is 7. So graphically, I'm going to solve it by graphing y equals 7, the right side of the equation, so that's this horizontal line. And y2 is the absolute value of 2x minus 3, which is this v. Okay. I just put both of these into GeoGebra. Just type y equals 7, y equals absolute value of 2x minus 3. And we want to see where they intersect. That's going to be the solution point. That's going to be the solutions to the equation, the x values of the intersection points. So that looks like negative 2. And this intersection point looks like 5. Negative 2 and 5. So the absolute value equation looks like it has two solutions. If I wanted to solve this algebraically, we know that this expression inside the absolute value bars, its absolute value is 7, which means that this expression could be 7 or it could be negative 7, because once we take its absolute value, we get 7. So we're going to write two equations. No more absolute value bars, right? We're going to say, well, if its absolute value is 7, then the expression itself, not in absolute value, could be 7, or it could be negative 7. And then we solve each of them. So we add 3 to both sides. We get 2x equals 10. Divide both sides by 2, and you get x equals 5. Over here, we add 3, and we get 2x equals negative 4. So x equals negative 2. And those solutions match the two we found graphically. Next, I want to solve this absolute value equation. I now know how to solve something that looks like absolute value of some stuff equals a number. So first, what I want to do is make this look like the absolute value of some stuff. So just get the absolute value by itself and have a single number on the right-hand side. So I'm going to start by isolating the absolute value. Add 5 to both sides. Those cancel, and I have 3 times the absolute value of 2x minus 1 equals 21. And then I'm going to divide both sides by 3 to get the absolute value alone. So I have absolute value of 2x minus 1 equals 7. And then I break this into two separate equations. If the absolute value of some stuff is 7, then that stuff is either 7 or that stuff is negative 7. And then we just solve both of these equations. So add 1 to both sides, and I get 2x equals 8. Divide by 2, x equals 4. And here I add 1 to both sides, and I get 2x equals negative 6. Divide by 2, and I get x is negative 3. Are our two solutions. To confirm, you can just take each of your numbers and plug them in for x and make sure that the equation is true for both of them. Our next topic for this lesson is solving quadratic equations. So those are second-degree polynomial equations, which means that the highest power you'll see on x is a 2. So they generally have this form: ax squared plus bx plus c equals 0. A, b, and c are numbers. We're already familiar with techniques used to solve linear equations. There are several methods we can use for quadratics. We're going to look at 3 of them: factoring, the square root property, and using the quadratic formula. To solve by factoring, we make use of something called the zero product property, which says that if you have a multiplication problem, multiplying 2 things together, so that's called a product. The answer to a multiplication problem is a product. Each of the 2 things you're multiplying are called factors. So if you have a product, a multiplication problem, whose answer is 0, a multiplication problem whose answer is 0, the only way you can get 0 to the answer to a multiplication problem is if one or both of the factors are 0. So if we can rewrite our equation so that one side is 0, maybe we can make use of this zero product property. So I'm going to add 27 to both sides here. So I have x squared minus 12x plus 27 equals 0. So that's the first step in trying to use the zero product property. You got to have one side be 0. Then the other side has to be a product. It has to be a multiplication problem so that you can set each factor to 0. So I have to factor this. We did a brief review of factoring in our chapter P, the beginning of the semester. So we're going to make a double set of parentheses. Some people call this the double bubble. And I have to think about what goes in this parentheses so that when I do first, outer, inner, and last products, I get what's up here. Okay, so it has to be that this is x and x. And then I need 2 numbers that'll go here and here that multiply to 27 but add to negative 12. They multiply to positive 27 but add to negative 12. So I'm going to go with negative 9 and negative 3. And you can do a quick check. X squared minus 3x minus 9x, that gives me the negative 12x plus 27. Good. Once we have it factored, I now have a product, right? This is like my A from up here, and the x minus 3 is like the b. I'm multiplying 2 things together, and I'm getting 0. The only way that can happen is if one or both of those factors are 0. So I solve these 2 things, and I get x equals 9 or x equals 3. Do keep in mind that factoring one side of the equation, like we did right here, is only useful if the other side is 0, okay? Because this property does not hold for anything other than 0. It's not the case that if you multiply 2 numbers together and get 20, that one number is 20 or the other number is 20, right? The 2 factors could be 5 and 4 or 10 and 2. So this is a very special property of when you're multiplying and the answer is 0. Visually, we can check our solutions to this original equation by graphing. You can graph y equals x squared minus 12x. That's this parabola. And y equals negative 27. That's this line here. And the x coordinates of the intersection points are your solutions. So we've got a 3 and we've got a 9. I also solved it by looking at this equation where I graphed y equals x squared minus 12x plus 27 and looked at where it crossed the x-axis because that's where the function is 0. That's where the graph is 0. So at 3 and at 9. It's just a visual way that you can confirm your solutions. Our next technique for solving quadratic equations is called by the square root property. The square root property says that if u squared equals c, then u is the square root of c or u is the negative square root of c. Okay? Or we'll sometimes say u equals plus or minus c. So if I want to use the square root property to solve this equation, first you want to try to get x squared by itself. So I've got 3x squared equals 27. So I'm going to divide by 3. And I get x squared equals 9. And then you say, okay, I know that if x squared equals a number, then x is the square root of the number or the negative square root of the number. So x, the two numbers you can square to make 9 would be 3 or negative 3. Because 3 squared is 9, but negative 3 squared is also 9. So our solution is 3 or negative 3. This is often abbreviated plus or minus 3. You can write it either way. One way to think about this property, or to help you remember the plus and the minus, is to use the absolute value rule we talked about earlier. We said that if x squared equals 9, we can say, okay, let's square root both sides. Okay, but the square root of x squared is not x. We just talked about this earlier. The square root of x squared is not x. It's the absolute value of x. So the absolute value of x equals 3, which means that x could be 3 or negative 3. Our third technique is called the quadratic formula. It can be used to solve all quadratic equations. The formula is derived from the general quadratic equation using an algebraic technique called completing the square. You can read about that in your textbook if you're interested. I'm not going to show where this formula comes from. We'll just use it based on the equation ax squared plus bx plus c equals 0. The quadratic formula says that x equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So first you identify the coefficient on x squared, x, and the constant. Those are your a, b, and c respectively. And then you just plug into the formula. So here's an example. Note that in order to use this formula, you first have to have your equation with 0 on one side. So let's subtract 4x and subtract 1 from both sides of this equation. So I have 2x squared minus 4x minus 1 equals 0. My a value is 2, b is negative 4, and c is negative 1. That's the coefficient on A, the coefficient on B, the coefficient on C. And then we plug into this formula. So we have x equals the opposite of B, right? So that negative sign, I like to read it as the opposite of, right? So B is already a negative 4. So I take the opposite of negative 4 and I get 4. 4 plus or minus the square root of B squared. So negative 4 squared, which is 16, minus 4 times A times C, all over 2 times A. And then we just do our best to simplify this. This becomes 4 plus or minus the square root. I have negative, I'm going to do the multiplications first because you always do multiplication before addition or subtraction. So I have negative 4 times 2 times negative 1, which is positive 8. So this becomes 16 plus 8 all over 4. So that's 4 plus or minus the square root. 16 plus 8 is 24 all over 4. I find this answer perfectly acceptable. Some of you may have been trained to reduce this, and it's not a bad habit to have at all. So 24 is not a perfect square, so we ask ourselves, does it have any perfect square factors? Yes, 4 goes into 24 perfectly. So I could rewrite this as 4 plus or minus the square root of 4 times 6 all over 4. Take the square root of the 4, so I have 4 plus or minus 2 root 6 over 4. And then you can break this into two separate fractions. So this is going to be 4 over 4 plus or minus 2 root 6 over 4, and then simplify each fraction. So I have 1 plus or minus root 6 over 2. Number 8, I have a third degree polynomial. 2x cubed minus 4x squared minus 30x equals 0. We don't have an equivalent formula for a cubic like we do a quadratic. So my best option is to try to reduce this into a quadratic. So every single term here on the left has at least one x factor. So I'm going to factor it out. I can also factor out a 2. So I'm going to do 2x times. 2x times what would give me 2x cubed, x squared. 2x times what would give me negative 4x squared, negative 2x. And 2x times what would give me negative 30x, negative 15. And now what's in parentheses here is a quadratic, and that is actually factorable. There are two numbers that will multiply to negative 15 but add to negative 2. So I've got 2x times x minus 5 times x plus 3 equals 0. And now I can use the zero product property on 3 factors, right? If you this is still a multiplication problem. If you multiply 3 things together and the answer is 0, if any one or more of them are 0, that's how you get an answer of 0. So I set each factor equal to 0. Either 2x is 0, or x minus 5 is 0, or x plus 3 has to be 0. And I get x equals 0, x equals 5, and x equals negative 3 as my solutions.